Okay, this is number 18 in your book, and I went ahead and I just wrote down the given information and our goal. And so we're talking about a population P of t, and it satisfies the extinction explosion equation, which is given here. And here B is AP squared and D is BP squared, and B is, so B for birth, this is the birth rate, and D is the death rate. And we're also given initial values here, where P is our initial population, right, and B naught, which is B of 0, and then D naught is the births per month and deaths per month occurring at time t equals 0. And the goal is to show that this M, which is the threshold population, that it equals this expression, right? Our D naught, our initial, right, deaths per month, and that's a P naught, and over a B naught. Okay, so since our goal is to show that M is equal to this expression, right, in terms of these initial values, these knots, we want to maybe get an expression using this differential equation that has knots in them, so we can show that that this is true. So I'm going to go ahead and just move this up. Oops. Okay, so this is basically a proof, and let me just make my mark a little bit smaller. Okay, so we know, so from page 81 in your book, we know that, so dp dt, the rate of population as time goes by, is equal to kp squared minus delta p. Okay, this differential equation, right, should remind you of this guy, right? I just have A and B, and the book has K and delta, but it's essentially the same thing. So if, well, this is in your book as well, but if we want, which we do want, we can factor out a KP, and when we factor out a KP, we're left with P minus delta over K. And this guy here, let me just maybe get a different color. This guy, right, that's going to be our M. So delta over K. And so that's our threshold population. So since I want to basically mimic, right, this differential equation here, then I'm going to do the following. So with my, let's do it on the side here. So I have dp dt, and I'm also going to factor, I'm going to do the AP just as I did with my kp. And when I factor that out, I get p minus b over a, right? And then this guy, right, is my m. So hopefully that makes sense so far. You want to mimic our differential equations. So what else do we know? We have, so let me go ahead and get a different color here. I think my laser pointer's not working, so I have to point with different colors. So I have, okay, so we know this, and we also have our initial values. Now, this part, right, my B and D, we know, let me just get my white here. Okay, so B is equal to A P squared. Well, I mean, that's really the same. I mean, we know B of T, right? The birth rate, that's the same thing as A P of T squared, right? We know it's a function of T. And similarly, because D is equal to B P squared, right? We know D of T, the death rate, is not, it shouldn't be a P squared, actually. That should not be there. So sorry about that. That is not there. That should just be B P. So I have these functions of T, and again, we're given these initial values, And well, I mean, we have a function, right, that describes the birth and the death rate. So I can say, well, what's b of 0? And well, b of 0 is just a p of 0 squared. But we know that b0 is just b naught, and we want the knots. And then this is just a p naught squared. And then similarly, with our death rate, we get d of 0, which is equal to, and I should really write p of t here. We have b, p of 0, and then again we have d naught times b and p naught. Now I can solve for a here, right? If I solve for a, I'm just left with b naught over p naught squared. Okay, so we have a nice expression in terms of our initial birth rate and population, initial population. And then here we can solve for b. So we have, let's see, d naught over p naught. Okay, so we know from above, right, that m is equal to, well, we know it's equal to b over a, actually, from page 81, which I talked about here. So if we write, let's go ahead and move this up. So we know, right, from page 81, that m is equal to b over a. Well, again, we want to show, we have our goal, we want to show m is equal to, what is it? Well, we have it above. So if it's b over a, well, I have a b here, right? It's d naught over p naught. And then I have an a right here. I have a b naught over p naught squared. And if you simplify that, right, just multiplying by the reciprocal and simplifying, we do get d naught p naught over b naught. So that is equal to our m, the threshold population, which is exactly what we wanted, right? Where is it at? Right here. So I apologize if the laser pointer is not working. On some videos it is, and some it isn't. Hopefully this makes sense. So this is number 18, which you will actually be using for number 19 in your homework problems.